This is R.d.sharma solution, class 12, chapter 19. Exercise is 19.25, indefinite integrals we are talking about. This will be cosec cube x dx. Now this is a very good question. How are we going to do this? We will try to find out the first function and second function. But wherever this cosec will come, we have to talk about cot also, or think about cot also. Because cosec and cot has certain relationship. What is that relationship? Cosec square x is equal to 1 plus cot square x. That you already know. Or you can call it as cot square x equals to cosec square x minus 1. So we will write cosec cube x in two separate terms. Cosec cube x will be cosec square x into cosec x. And this cosec square x, now I told you that cosec square x can be 1 plus cot square x, so you will be tempted to write cosec square x as 1 plus cot square x. But when we see this cosec x, the second term, what we will do? Just take that imagination. If t equals to cot x, dt by dx will be what? Because the differentiation of cot x we know. This will be negative cosec square x. So we have a cosec square x now. So why not to convert this cosec x into this form 1 plus cot square x. So if I remove this square, it will go on the right with a root. This, we are just swapping these two terms. Cosec x will be written as under root 1 plus cot square x. And this cosec square x, as I said, that I am writing it after this under root 1 plus cot square x. And then with a dx. Now when we write this cot x as a t, or when we take this t equals to cot x, we will get this cosec square x dx from the differentiation. So if we assume cot x as t, it will be under root 1 plus t square, and the differentiation of cot x with t will give you what? It will be cosec square x dx will be negative dt. So you can write this dt. Now you know under root a square plus x square has a direct integration that has been discussed already. We will take a as 1 and x as t. So the integration will come like this. It will be t by 2. I am writing this under root a square plus x square, that will all come in plus. But because of this negative sign in front, both the terms which are the result of under root a square plus x square, and here in this case under root 1 plus t square, both terms will be negative. So t by 2 under root 1 plus t square minus this a square by 2 log, and inside that log we have a modulus t plus under root 1 plus t square and plus constant of integration. Now these both negative signs are just because of minus dt, which we earlier discussed. So these two negatives are there. Now let's do the final replacement, because t was taken as cot x. So this will be negative cot x divided by 2 under root 1 plus t square. What was under root 1 plus cot square? It was simply cosec x only. So let's replace under root 1 plus t square as cosec x. 1 by 2 log modulus t is, of course, cot x we have taken, and under root 1 plus t square already being done, it's cosec x finally. So this will be plus cosec x inside the modulus sign plus constant of integration. Now you can resolve it, I mean simplify it. When you have cot x, it's cos by sine, cosec x is 1 by sine. So we are not getting anything, it's not cancelling as well. So we will keep it like that. Negative half cot x into cosec x. How about the second term? The second term, we have cot x plus cosec x inside. So let's do it here. Cot x is cos by sine. Cosec x is 1 by sine. So we can take the LCM, which is the sine, 1 plus cos x. 1 plus cos x by sine x. Now 1 plus cos x is always very near to us because it's 1 plus cos 2 theta. You already know it's can be related with cos and sine. 1 minus cos 2 theta, 1 plus cos 2 theta. So 1 plus cos x can be written as 2 cos square x by 2. And sine theta is 2 sine theta by 2 cos theta by 2. That is 2 sine x by 2 cos x by 2. 1 cos can be cancelled, 2 can be cancelled, the number 2. Cos x by 2 by sin x by 2 will become cot x by 2. So minus half log this cot x plus cosec x after simplification can be written as cot x by 2 plus constant of integration. Now you can keep it like this, but if you want more, simplification, or in order to match the answer with the R.d.sharma solution, this negative half log cot x by 2. We know that cot x by 2 can be written as 1 by tan x by 2. Tan x by 2 is simply 1 by tan x by 2 is tan x by 2 to the power minus 1. When you have a log, the power comes in front. So this negative will come in front. So you can have a plus here, half log, and you can just write tan x by 2 in place of this one. So it will be tan x by 2 plus constant of integration. That's your final result. Now this is the result, or this is the reference you can use at how to write. So the next question is sec inverse under root x. Please remember there is one more question which is coming up with the same kind of formation. So you need to understand this very well. Now there are functions. Sec inverse is one function. Under root x is inside sec inverse. This is another function. So we all normally in this exercise we have a dot b. A is one function, b is another function. So we take a as first function, b as second function, and we apply the formula and go about integrating it. But here the second function is the theta of sec inverse. So we will devise a new thing, which is we will assume that 1 is already there. I'm not assuming it's already there. 1 is already there. So 1 will be taken as one function and sec inverse under root x will be taken as another function. And which is integrable? Which one of these is integrable? That can be taken as the second function, because in the formula the integration is done for the second function. Which is the better one? If you want to integrate sec inverse under root x, that will again be a problem because that is the question only. So we will assume sec inverse x as the first function and 1 as the second function. So sec inverse under root x will be the first function. Integration of this one is 1 dot dx, that is 1 we are going to integrate, minus integration of, two things are to be done here. First, the differentiation of the first function, which is sec inverse under root x, then multiplied with the integration of the second function, and when we multiply these two, then result will be integrated again. Sec inverse under root x, integration of 1 dot dx, or integration of dx is simply x, minus integration of, I'll just do sec inverse under root x, but integration of 1 dx I'm writing as x. But sec inverse under root x has a direct differentiation. Now this is not the chapter of differentiation. Sec inverse under root x differentiation already been done. Please revisit it again. I am going to write the direct result here. First you have to use the formula of sec inverse theta, integration, differentiation of sec inverse theta, then that theta is actually under root x here. So you have to do the integration with root x as well, differentiation of root x, and divide it again. So I'm writing it 1 by under root x and root 1 minus x into 1 by 2 root x. This 2 root x has come from the differentiation of under root x. Now under root x multiplied will give you x, because under root means power of half. X to the power half, x to the power half. And when you multiply this, half gets added and it will become 1. So this under root x can be cancelled with the numerator. So we are only left with 1 by under root 1 minus x. Now again under root 1 minus x has already been done as an integration, because it's simply 1 minus x to the power minus half. When you integrated it, 1 minus x to the power minus half plus 1 divided by minus half plus 1 with simple integration logic. But 1 minus x, which is inside, is to be differentiated. It will give you -1, and that has to be divided. So 1 minus x differentiation is -1, and that also has to be included. So -1 here. So 1 minus x to the power half here. -half plus 1 is half, and negative is already there. This 2, which is in this term, and what I showed you of integration of 1 by under root 1 minus x, this minus has, we will keep it like that, but this 2 and half which is in the denominator gets cancelled. because half will go up and 2 is already in the denominator. So we are dealing with a negative, that I will make it as positive. X sec inverse under root x already been done. And since we have a negative here, I'm making this as a positive. Just now I'll do it. And already the integration has been done. So I'll write the direct result. This negative will become positive because of this negative. If you can just imagine how this negative has come here. And 1 minus x under root you can write, or 1 minus x to the power half you can write. So this is the way you are going to go about it. It's a very good question. And this is a very simple solution so that you can have a reference here. So please keep remembering the negative positive signs. So as I was mentioning you that sine inverse under root x, it's almost similar to sec inverse under root x. So we will be tempted again to solve this in the same way which we have just did. But you will be surprised to know this question will be done in a different way. How? We have a sine inverse under root x, and we know when we differentiate under root x, it will be 1 by 2 under root x. So we will introduce this under root x in the denominator. And when we have under root x in the denominator, we have to have a root x in the numerator because we have introduced it. We cannot have anything without cancellation. And we will put root x as t. When we take this t equals to root x, dt by dx will be what? 1 by twice of under root x. So this dx by under root x will form 2 dt. So we have dx by under root x. Now if we integrate this with respect to dx, dx by under root x has already been showed just now. That can be kept as 2 dt. So now after taking t equals to under root x, this integration of introduction of under root x by under root x has become t, because root x is t, sine inverse root x is t, so sine inverse t, and dx by under root x has become now what? It's just 2 dt. So I'm bringing this 2 in front of integration and keeping dt. Now from here this question will start. Until now we have just done some simplification, but actual integration according to this exercise is t sine inverse t. Now this sine t into sine inverse t, we will take one function as the first function, the other one is the second function. But we have to see the integrability also. That's why we have to take sine inverse t as first function and t as the second function. So this sine inverse t will be the first function, then the integration of t dt minus integration of differentiation d by dt of what? Sine inverse t. This is the first function, and the integration of the t dt. And when we multiply these two, again an integration will be performed. Sine inverse t remains like that. Integration of t dt is simply t square by 2, you already know that. Minus integration of, what will be the differentiation of sine inverse t? 1 by under root 1 minus t square. That is a standard result, you already know that. T dt already done, t square by 2, and then we have a dt here. Now we have to integrate this one, the second part. First one is already done. The answer has already come for the first. We'll replace t in the later discussion just now. But we will concentrate on the second part, which is integration of 1 by under root 1 minus t square into t square by 2. 2 is already there with us. If you remember this 2, this has to be multiplied. 2 was already there. So when you multiply these 2, the denominator 2 will be cancelled. So you can just cancel this 2 and this 2 and this 2. Alright. So we have actually gotten rid of this 2. So we will integrate the second part now. Integration of t square divided by 1 minus t square. That's what we have to do. So we will try to have a 1 minus t square in the numerator. So when we take this 1 minus t square, so we have to have a negative outside because it was just t square in the numerator. So we have to include a negative one also. So when we multiply this 1 minus t square minus 1 with a negative, we will have this t square. Now we will separate them out. Negative we will deal later. So let me just multiply here and make it as a positive only. Okay. So I'm making it positive just because if I forgot to keep this negative, then that answer will be wrong. So I've multiplied it and kept this as positive. Now I'm separating these two out, 1 minus t square by under root 1 minus t square and negative 1 by under root 1 minus t square. Now this integration of 1 minus t square by under root 1 minus t square is quite simple. If you take 1 minus t square as some say p, it will be simply p by under root p, and anything with p by under root p, you can just use that half, 1 by half or power half, that is 1 minus t square, 1 minus t square by half. This will go, when it goes up, it will be 1 minus t square by minus to the power minus half. 1 minus half will be half only. So ultimately you are integrating under root 1 minus t square. So actually the first term here, you are integrating under root 1 minus t square. So this 1 minus t square is simply under root a square minus x square. And the second term is minus integration of 1 by under root 1 minus t square. And both of them have the direct result. 1 by under root 1 minus t square is sine inverse t. That is the final result, means the standard result. And under root a square minus x square, which is actually emulating or similar to under root 1 minus t square, direct result can be written. So this will be, the first term is, which we already done. I am writing t square into sine inverse t. Now I am writing the result of under root 1 minus t square, which is actually similar to under root a square minus x square. It will be t by 2 under root 1 minus t square minus half sine inverse t, and the last will be integration of 1 minus integration of 1 by under root 1 minus t square, which is direct result, which is sine inverse t. So minus sine inverse t, and this will be plus. There is a slight change I am doing it. Please be aware of the negative and positive sign and the constants. Okay, this can be a final result, but since we have sine inverse t in this half and negative 1, we can just combine these two. Half minus 1 is negative half only. So t square sine inverse t plus t by 2 under root 1 minus t square, and this will become negative half sine inverse t plus constant of integration. And only one thing is remaining. We have to replace now t by under root x, which was initially taken. So it will be x sine inverse under root x plus under root x by 2 under root 1 minus x minus half sine inverse under root x plus constant of integration. And if you want, you can resolve it again. How you can resolve it? Because we have a sine inverse x in two terms. So you can combine these two terms, the first term and the third term. So if you take this sine inverse under root x common, this sine inverse under root x common, x minus half will come. So x minus half will give you what? 2x minus 1 by 2. So 2x minus 1 by 2 sine inverse under root x. And you can multiply this under root x into under root 1 minus x. It's simply under root x into 1 minus x. That will give you x minus x square inside a root by 2 plus c. So that's your final result. So this was a very good question, and it needed a lot of effort, and all the concept we have learned is applied here or learned here. So you can solve it like this. Okay. So the x tan inverse x, this question, when you can differentiate tan square x or integrate tan square x, that will decide which one has to be taken as the first function or the second function. So I'm writing this as x and tan square x as sec square x minus 1, because we know that sec square x has a direct integration. And when you have this sec square x minus 1, you can separate them out. It can be written as x sec square x minus x. When you integrate these two, take this dx along. Integration of x dx is quite subtle and easier, x square by 2, and we are just keeping it in our temporary storage, so we'll just get it back whenever we require it. So we are going to integrate this x into sec square x dx, which is our main priority right now. We will imagine which can be integrated, and that will decide which will be taken as the first function. So we'll take first x as the first function, sec square x as the second function. So x integration of sec square x dx minus integration of d by dx of x integration of sec square x dx. This is, I am directly applying the formula which we have discussed earlier. X square by 2 is already there. We'll just add it in the final solution. So integration of sec square is tan x, so x tan x you got. Differentiation of x is 1 and integration of sec square is again 10x. So x tan x minus integration of 10x. So we have x tan x, and what is the integration of 10x now? Integration of 10x is direct result log modulus of sec x. And already the temporary storage has x square by 2, so I'm adding it now, negative x square by 2. So there will be certain constant of integration from all the terms. We will combine them in a single constant of integration. So this is your final answer. X tan x minus log modulus sec x minus x square by 2 plus constant of integration. And this is the result which is in front of you. You are doing it by yourself. Just follow this scheme. Don't forget by writing all those English terms. This question will be taken later. Thank you so much. Have a good one.